Okay, all right. So let's consider the quiz first. All right. So question 6. Nick, can you read it for us, please?
Yes. Assuming alpha is opposite A and beta is opposite B and theta is opposite C, solve each triangle if possible. Round each answer to the nearest tenth. Alpha equals 43 degrees, theta equals 69 degrees, A equals 20.
Very good. All right. So now just this one is called as a Greek letter. This is gamma.
Yep, that's theta.
All right. This is a gamma. Okay. All right. So let's consider this one. We are given two angles and one side, right? So alpha, beta, and gamma equals, the summation is 180. So we have beta equals 180 minus alpha minus beta. We found that's 68 degrees. By law of sines, we have this equation, right? 20 over 20 is A, 43 is alpha, so 20 over sine 43 equals B over sine. It's going to be beta is 68. We just found it. Beta is 68 equals C over sine 69, right? 69 degrees. Then we can find B equals multiply sine 68 times this one. Okay, we got 27.2. C equals this one times equals 27.4. All right. So therefore we have, all right, alpha, beta, gamma, A, B, and C. So we solved this triangle. We got all the angles and the sides, right? So this is question 6. Okay. Now question 20. Mustafa, can you read it for us, please?
Assume alpha is opposite side A, beta is opposite side B, and gamma is opposite side C. Determine whether there is no triangle, one triangle, or two triangles. Then solve each triangle if possible. Round each answer to the nearest tenth.
Okay, very good. All right, so we have A is 7, B is 3, beta is 24 degrees, right? So now this one is given two sides and one angle, right? Two sides, one angle. So for two sides, one angle, you got to determine, right? So there are 4 different situations. No triangle, right? There is a red triangle, or two triangles, or there is one, right? So for this one, you have to determine first. Now, firstly is the angle. Now this angle is beta, right? This angle is beta. Angle is beta. So the adjacent side, the opposite side is B, right? The opposite side is B. And A is going to be an adjacent side. It's one of the adjacent side, right? So A is 7 here. So B is, beta is the angle, 24 degrees. B is the opposite side, right? So now you got to determine the height, right? Based on the adjacent side and the given angle, right? So that is going to be our h, right? That is going to be our h, correct? So you determine the h, right? Determine the h. So for h, as we know, by the law of sines, we have 4 different situations. Now there are, we can determine them by what? Okay, still again here. All right, so it is somewhere here. Okay, here we go. Now you can see that h is a very important quantity here, right? It determines whether there is no angle, right angle triangle, two triangles, or one triangle, right? So that's a really important to know what h is, right? What h is. Now, how to determine the value h? Okay, in this example here, we have the angle is alpha, right? Now, which is the given angle, and A is the opposite side, right? Alpha, the opposite side is A. B is the adjacent side, right? So Now this one is just a given example, right? So if the alpha A, B are given, right? So but you really need to know this, the angle, right? The opposite side and what? And one adjacent side. Adjacent side, right? Angle, opposite side, adjacent side. Now this H equals B is the adjacent side for this one, right? So actually this height equals what? Adjacent side. Times what? Sine of the angle. All right, it's the adjacent side times the sine of the angle given, right? Okay, the adjacent side of the angle times the sine of this angle. Now, like what this means, right? B is adjacent of alpha, right? B times sine alpha. That is going to give us H. Yes? Okay, so that's very important, right? So here is, all right, the given angle is beta. The adjacent side is A, right? So H equals the adjacent side is A times sine of the angle, beta. Okay, so this is going to be your first step because this is so important to determine what? Whether you have no triangle, one triangle, or two triangles. Okay, so now let's find H. H equals A times A sine beta, right? Which gives us what? 2.847. I should give another one. Okay, I forgot. But anyway, this is okay. Okay, so this is what we have here. H equals 2.8 something, right? Now, based on the category here, right? H is 2.8, and we know that it is greater than less than A. Okay. It is a third case. All right, so we know that. Oh, sorry. Since well, no, not this one. No. H is less than A, right? And what? A is less than B, right?
Question.
Okay.
If A is 7 and B is 3, how is A less than 7?
No. Yes. This is a typo here. This is a typo here. Sorry. B is less than A. Yes, this is good. B is greater than A. But this one is the opposite side, right? The opposite side is less than the adjacent side. Basically, that's what this means, right? The opposite side is less than the adjacent side. And what? H is the smallest one, right? H is less than the opposite side and also less than the adjacent side, right?
Okay.
So basically, that's what it means here. So H is less than A, less than B. Yes. Adjacent side, opposite side. But no, opposite side, adjacent side, right? So H is the smallest one for the third case. Is that the case? I believe so, right? H is 2.8, something 47. Less than B, B is 3. Is less than what? A. A is 7. Now this is good. Does that make sense? H is the smallest. It's less than B and less than A, where B is the opposite side of the angle beta. A is the adjacent side, right? So therefore, we have the third case. That is, there are two triangles. Okay, so this is the deciding point. All right, so this is the deciding point. So it's really important to get the value of h. Now, however, in order to get the value of h, you need to know what is the known angle, right? For this one is beta. What is the opposite side? What is the adjacent side? Now, h is the adjacent side times sine of the known value, known angle, right? So that's what we have. 20. Okay, so h equals this one. Does that make sense?
Mhm.
Okay, so since we have this one, there are two triangles. Now, by law of sines, we have alpha. All right, so sine alpha over 7, 724 is beta over b, 3 equals sine alpha, alpha over a, right? So over 7. Now we found that sine alpha equals 0.9491 and alpha equals what? Either this one or 180 minus this one. Two possibilities, right? Two possibilities. Now, there are two situations. When alpha is 71.6 degrees, we can find gamma is 84.4. By law of sines, we find C equals 7.3. Therefore, we have alpha, beta, gamma, A, B, and C. Now, of course, this is the first situation, right? When alpha is 71.6 degrees. Does that make sense? All right. So when alpha is 108.4 degrees, right? We find that gamma is 47.6 degrees. By law of sines, we have this one. Found C is 5.4. Then alpha, beta, gamma, A, B, and C are given here. Right? This is the second triangle. Okay, this is the second triangle. Okay, so you may see this one. Right? This one is like something. This C is larger. C is something like this. All right, and this is beta. This is 7, this is alpha, this is gamma, and this is C, right? C is 7.3. Okay, and this one is what? 3, I believe, right? So this something looks like this one. All right. So this is the first triangle, right? Another so here is H. Here is H, right? So the second one is going to be what? Something like this one, right? So it's going to be something like right? This is alpha. This is beta. This is A, alpha, and this is gamma, right? So you will have this one, similar, something like this. Okay, so the other one is going outwards of this H here of the right triangle. The other is inwards, right? So these are two different triangles we have. Good. All right. There are several of us made errors on this one or missed one triangle at least. Okay, so just be careful on this one. So question 20, question 30. Salim, can you read for us, please? Salim?
Yes. Find the area of the triangle with the given measurement. Round each answer to the nearest 10. A
Okay.
equals 7.2, B equal 4.5, gamma equal 43 degrees.
Okay, very good. All right, thank you. All right, consider this one. So this is very simple, right? So we're just using the formula for the area, 1/2 times 2 sides and the angle between them, right? So for this one is 1/2 AB times the sine of gamma, right? Sine of gamma, because in a triangle, this is A, this is B, and this is C. This is going to be alpha, this is going to be beta, and this is going to be gamma. So AB, the gamma is the angle between A and B, right? So therefore we are good. Right, we're good to go. It's 11.1, 11.0. Okay, round to the nearest tens. Okay, good. Okay, so this is about the quiz. Now let's consider the homework. Now for the homework today, we are going to go through two sections, right? So one is section 9.5, the other is going to be 10.1. Okay, now let's firstly do 9.5. Any questions do we have on this section?
Can you do
I have a question.
25?
25? Okay, let's do 25 first. All right, so let's do this one. 25 first. Okay, so 25. All right, so we want to find exact solutions on this interval. So this one is what? This one is about the quadratic equation, right? This is a quadratic equation about cosine, right? So we will have what? 2 cosine square t plus cosine t minus 1 equals 0. Yes? And then you can just using the quadratic formula to find the cosine, right?
My problem with it is I use the quadratic and I keep getting different answers from the answer choices, like in the back of the book.
Okay, let's do that then.
For multiple like homework examples, I kept getting different.
Okay, let's see why. All right, so we compare your what you did with what we have here. All right, so then cosine of t equals what? 2a, 2 times 2, negative b is -1, right? B is 1 here, right? And the plus minus square root of b squared, 1 squared minus 4 times 2 times what?
-1.
-1. All right, because c here is -1. All right, so this one equals. Now on the bottom is 4. This is -1 plus minus. What's in the under the square root sign?
I got 9.
You got 9, right? So square root of 9 is what? 3.
That'd be 3.
Yes. So cosine t can be what? -1, -1 plus 3. That's 2, right? 2 over 4. That's 1/2. Yes. So we have cosine t can be 1/2. Yes. Cosine t equals 1/2, or what? Can it be negative? -1, -3, -4, -4 over 4, -1. Can cosine t be -1?
Yes.
Yes. The range is from -1 to 1, right? So it's within the range, so it is possible. Now, over the interval 0 to 2 pi, for what values cosine t equals 1/2? Using the unit circle, t equals what?
5 over 6.
No.
Nope.
Pi over 3. Okay, it's pi over 3 for cosine, right? Sine 1/2. Then t equals to pi over 6, right? For sine. For cosine is pi over 3. And another one is what?
5
4
pi over 3.
5 pi over 3. Right? Now what about this one? Cosine of t equals -1.
Pi.
That's going to be pi. Right? That's going to be pi. So between 0 and 2 pi, that's going to be pi. So that's going to be the 3 values. Mustafa, did you get it?
Yeah, I forgot to take the square root of 9 and just kept 9.
Oh, okay.
itself.
I see.
That's what I did.
Yep, I see. Okay, cool. Let's see. Do we have any other questions on section 9.5?
Can we do 35?
35. Okay, 35. Now 35 here. Okay. we want to solve, right? We can solve this equation over the interval pi 0 to 2 pi. Okay, so let's consider this one. Now this one is using the sum and difference formulas, I believe. Yes. So on the left hand side, it is firstly a product of two cosines, right? And then a product of two sines. In the middle, that's plus, right? So it is the sum formula or the difference formula for cosine, right? It is going to be cosine, right? So it's cosine what? Difference, because this is a summation, right? So cosine of the first angle is 2x, second angle is x, 2x minus x. That is what we have on the left-hand side, which equals what?
1.
Cosine x, right? So this means cosine x equals 1. So what is the x value? If cosine x is 1 over the interval 0 to 2 pi, x equals what?
0.
0. So x equal to 0.
My question about that is, why didn't we use 2 pi with it? Why not 0 and 2 pi? Because it says from 0 to 2 pi.
This is open parenthesis on the right. So 2 pi
That's
is not
why.
2 pi is
Oh,
not
okay.
included, right? So 2 pi
Okay.
is not included. Very good though. All right. So if 2 pi is included, the bracket there, then definitely 2 pi should be included, right? But for this one, we do not have 2 pi there. Does that make sense, Salim?
Yeah.
Okay, very good. Other questions?
29.
29. Okay, let's do that. 29 here. Okay, find the exact solutions here. Okay, so second square x equals 1. So what is the second value? Second is x. Can be what? Positive 1 or negative 1. Yes? Second x can be positive 1 or negative 1. Yes?
Did you just take the square root?
Oh, well, you cannot just take the square root, right? So because as we know, x squared equals 1, this implies what? X equals plus or minus 1. Yes? It can be positive 1. It can also be negative 1. Yes? Okay? So you got to be careful. You cannot just directly take the square root, because this is not a one-to-one, right? So here for this one, it can be positive 1 or negative 1. So now you know that 1 square of 1 is 1, square of negative 1 is also 1, right? So it can be positive 1 or negative 1. Yes, you cannot miss negative 1 there, right? You cannot miss a negative 1 here. So now from this side, then cosine of x equals 1, right? And for this one is negative 1. Yes? So cosine x can be 1 or negative 1, so it can be 0 or what? Or 0 or pi, right? 0 or pi. Okay, does that make sense?
Ironically, in the book, it actually only gives the value as 0. Is the answer they give in the book.
Oh, really?
And they
Then
give 0 and pi.
it gives
29.
0.
I only give
20.
0.
Really?
Oh, I'm sorry.
It's 0 and pi.
I
0
looked at
and
the
pi.
wrong one. I'm sorry.
Okay, okay. Yeah, it should be 0 and pi. Yes. Okay, very good. Okay. Very good. That's why we you know, we have a group then you know, like we have more eyes, and we don't make errors, right? So that's good. Okay, so any other questions on this section, please? Mustafa, you're muted.
Oh, 37.
37. Okay, let's do 37.
Awesome. Promise.
30. Oh, 37. I bet. Oh no, we didn't do this one, right? Okay, we didn't do 37. Okay, let's do this one, right? So 37. No, I think we did this one in last class. Mustafa.
Yes, we have done it.
Yeah,
Yeah,
we did 37. We talked about this one in last class.
Mhm.
You may check. Okay, so we did this one in last class, which means what? We want to use a formula like a cosine 2 theta equals 2 cosine square theta minus 1, right? So we want to use this equation. And then when you plug in here, you got a quadratic equation about cosine.
Okay.
All right, so then you can do that. All right, so this is something we did, I believe, in last class. Or you may check the notes from last class. Okay, very good. Any other questions on this section?
That was the one I asked about last time, actually, I think, if I
Yes,
recall.
yes. Okay, all right, then let's move on to 10.1 exercises. 10.1.
I have a question about number 13.
Number 13. Okay, very good. Let's do number 13. Number 13. Number 13. Number 13. Number 13. Number 13. Where is it? Where is it? Oh, S. Is that this? Oh, yeah, it is here, right? This one, right? Okay, very good.
Yeah.
All right, number 13. All right, let's do this one. We have used the law of sines, solve missing side of each oblique triangle, right? So we have everything that this is angle. These angles are using capital letters, right? Using capital letters. Okay, but it's the same. All right. Find side C when B. All right. This is like a beta, right? 37. C is this one, and B is 23, right? 23. Now this one is you're given two. Well. I believe this is something this is using capital C, right? Capital
It
C.
should be
This should be
degrees on it.
21 degrees instead. Okay, very good. Natalie, we found an error from the textbook. Okay, cool, very cool. Okay, love that. Okay, this should be 21 degrees instead. Okay, so if there's 21 degrees, then that should be no problem, right?
Yeah. I
Okay.
didn't know.
Okay, there should be 21 degrees. Sorry.
If you did like I did, you went to radians and then you saw the degree number like over 1,000 degrees. Like that's not going to work.
No, yeah, that's very good. Okay, so so then any other question on this section, please?
65. I didn't.
65.
Yeah.
Right. Let's go with 65 then. 65. Oh. Oh gosh. Okay. 65. Okay. All right. So Nick can read for us, please.
Yeah. A pilot is flying over a straight highway. He determines the angle of depression to two mile points 4.3 kilometers apart to be 32 degrees and 56 degrees, as shown in figure 33. Find the distance of the plane from point A to the nearest tenth of a kilometer.
Okay. All right. 2 mile post is 4.3 4.3 kilometers, right? So AB, this distance is 4.3. Yes, correct. Okay, this is what we have here. All right, so we have the angle of depression as shown. From A is 56, B here is 32 degrees. Now, then what is the angle of we consider the triangle here, right? AB, let's say this is a C. Let's consider the triangle AB and C, right? AB and C. Now, What is the angle of this one? Can we find this one?
24 degrees.
This is going to be 56 minus 32, right? So angle C equals 56 degrees minus 32 degrees. That's 24 degrees. That makes sense? Now, do we have another angle? Can we find another angle?
I find angle B, which is 32.
Yeah. All right. We also see that this is another angle, right? Nick, did you see this angle? These two lines are parallel, so this should be also 32, right? So angle B is 32 degrees, right? Then what? You have two angles and one side, right? So by law of sine, you can find the value of all the sides, right? All the sides. This is going to be, but you just need what? The distance of the plane from A. So you just need the sides AC, right? So which is B. You only need value for B. So I believe is you can do B over sine B equals, this is going to be C over sine C, right? Okay, so you can just solve this one.
Okay, that makes sense.
Okay, very cool. Okay, all right. Any other questions, please? Good. Okay, all right. Let's now move on to our lectures. No. Before we move on to lectures, this is the announcement about the test, right? Test 2. So we're going to have our test this Friday, which is tomorrow, right? Test will be from 11:10 to 12:10, 1 hour test. I believe this test will be shorter. Okay, will be shorter. In test 1, we have 11 questions, right? Now, this one, we just have 9 questions. Now, I hope, all right, it will take shorter time. All right, so it's going to take shorter time. All right, but still, again, you have to to take to put efforts in the preparation. All right, so that's going to be some challenging part, right? So it's like this section, this chapter, this is just a chapter 3 is by nature harder, right? So, but I will assure you that the test problems is going to be very close to the examples in the lecture notes, and also test the homework questions and the quiz questions. Right, it's going to be very similar. All right, to some of them. So, all right. So the test covers everything from the inverse trigonometric functions, all right, which is section 2.3, to today's class, right? Today is going to be law of cosines. Okay, so inclusive. All right, inclusive. That's going to be from test 1 up to now, up to today's class, right? So, you need to have your camera on. Solving both tests, calculators are allowed. You need to submit the test like what we did for the quizzes. Everything is the same for test 1, right? It's similar. Okay. If any questions, okay. So I believe that's that, right? Now, good.
Good.
Okay. All right. So that's the policy about test 2. Now, let's move on to our lectures. Section 4. Okay, so now in last class we talked about law of sines. Today we do law of cosines, right? So today we do a law of cosines. So what is the law of cosines? Consider this one. This is a triangle in the standard position. Well, it's not in the xy coordinates, right? So A is in the origin. C is at the point B cosine and B sine, right? So now if we consider this small triangle, right? This triangle in red, okay? So what do we have? This is a right triangle, right? This is a right triangle, correct? So we will have what? It seems like it is this distance. Well, I believe this is b. This point is b cosine is x, right? X here. This distance x equals what? X is the x coordinate of c, right? If you can see here, this x is the x coordinate of point c. So x is what? B cosine theta. Yes. Y equals what? B sine of theta, right? Make sense? And this side is the hypotenuse is a, right? So we will have x minus c. It is this side, all right? Square plus y square. This one should equals what? A square. Yes, it's a right triangle. Pythagorean identity, right? So we have this theorem. So this implies if you plug in, right, everything, then b cosine theta minus c square plus b sine theta square equals what? A square. Yes. Okay, so just a plug in, right? Now let's open the square for this one. So what do we have for here? So b square cosine square theta plus c square minus 2. The first term is b cosine theta and times c. Yes. And plus, okay, so here is b square sine square theta equals what? A square. Correct? So then we see that, okay, we can put these two together. Yes. So this implies b square of cosine square theta plus sine square theta plus c square and minus 2b cosine theta times c is 2bc cosine theta. Yes. Now this one equals a square, right? Now we have cosine c square sine c square equals 1, right? Pythagorean identity. So this implies what? A square equals b square plus c square minus 2bc times cosine of theta. Does that make sense? All right, we got an equation involving cosine theta, right? Involving cosine. Now, gives the square of the opposite side. And you see A is the opposite of theta, right? The opposite side of theta. Giving the length of the opposite side, A square, right, equals what? B square plus C square, which is two adjacent sides of this angle theta, right? Two adjacent sides. Times cosine what? Minus 2bc times cosine of the angle of these two sides, between these two sides, right? So this is the result. Okay, this is the general result of law of cosines. In general, we have this one. Okay, the law of cosines states that the square of any side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the included angle. Okay, that is the law of cosines. Now, for triangles labeled as in figure below, this is alpha, beta, gamma, A, B, C, right? A is opposite to alpha, B is opposite to beta, or gamma, C is opposite to angle gamma, right? So the law of cosine gives what? Now, the opposite side of alpha, a squared equals b squared plus c squared minus 2bc cosine alpha, right? Now, any side. So for b, the opposite angle is beta, right? It's beta. So it's going to be adjacent side is a and c. So a squared plus c squared minus 2ac cosine beta. Now, for the last one is c. C is opposite to gamma. So the two adjacent side is AB. So AB squared plus B squared minus 2AB cosine gamma. Okay, so that's the law of cosines. It gives what? A formula to find the size of the opposite side, right? Involving what? Cosine. Involving cosine, the two sides that includes this angle. Okay. So that is the law of cosines. Okay, let's consider an example here. All right, just consider one example about the law of cosines. Right, let's consider one example on how to use the law of cosines to solve a triangle. Right, to solve a triangle here. So basically means we want to find out these ones. Now another one is given the three sides, we can also use the law of cosines to determine the cosine value of alpha of any triangle. Okay, so this is another way to state the law of cosines, which is if the three sides are given, we can determine the cosine of the angles. Now that's what we mean by the second part of the law of cosines. Now, when solving a triangle, the corresponding opposite sides measure is needed. We can further use another version of the law of this one to solve for an angle, right? So what is cosine alpha? Is b squared plus c squared minus a squared over 2bc. Cosine beta equals the two adjacent angle. Sorry, here is minus b squared. All right, minus b squared over 2ac. Now for gamma, this is a squared c squared. Sorry, it's a typo. Right, and it should be c squared. Okay, cosine gamma equals a squared plus b equals minus c squared over 2ab. Okay, where you see that the this is the cosine of the angle. Let's say theta, right? Equals what? Adjacent 1 square plus adjacent 2. Okay. A1 square plus A2 square minus O square, right? Times 2A1, A2. Where what? A1, A2 are the two adjacent side of theta. And O is what? Opposite side. For any theta, right? So this is how you memorize this one, right? So you use on the top, it is the sum of the squares of the two adjacent sides minus the square of the opposite side. That's on the top. On the bottom is 2 times the product of the two adjacent sides. Yes? Okay. So then you can just, this is going to be summarized the 3 formulas above. Okay. So these are the, how can we use the law of cosines to solve a triangle? Okay. So if these are given, these certain information are given here. Okay. So now let's do an example. Natalie.
Find the unknown side and angles of the triangle in the figure.
All right. Very good. Thank you. All right. So let's consider this one. Solution. Okay, so we're given A and C and the angle beta, right? Angle beta. Now, can we find the unknown side B? Yes, right? We can find the unknown side B. So B is the opposite side, right? Opposite side of gamma. So B squared equals A squared is adjacent sides, right? 10 squared plus C is 12 squared, right? The square sum of the two adjacent sides minus what? 2.
Oh.
No. This is the first one, right? We want to find the size, right? Minus what? 2 times AC, right? 2 times 10 times 12 times cosine or sine
Cosine.
times cosine 30 degrees. Okay, so then you can just plug in everything, find this value, see what do we get. Okay, so what did you get? Anybody got this?
I got 36.1539.
Do you mean the squares?
Yeah, I did this.
Oh yeah.
Oh, I'll take the square root of it.
No. Oh no. You should get it right. What did you get, Mustafa?
The square root of 36.
No. What is a square? What is a square? Square is what?
36.153.
3 what?
9.
3 9.
9.
Yes. You got this? Good. Okay, very good. Then this implies what? B equals, well, B is positive, right? So it's going to be square root of 36.1539. So this will be what? What do you get for this?
$6.10128.
6113?
No. That's 6.01. 6.0128.
0128. Okay. So that is the value for B, right? That is the value for B. Now then we need B is known, right? So 6.0128. Now what about, we are also want to find the angles, the missing two angles, right? So one is alpha, one is gamma. How can we find alpha and gamma?
We use the second equation.
Using the law of cosines, right? The alternative version, right? Another version, this alternative version of the law of cosines. Now, but before we do that, can we use the law of sines? I believe so, right? So we can use the law of sines, I believe, because we have this size and 30 and so on, right? So we may just use the law of sines. Works. You may try that. All right, you may try the law of sines. But in this example, we want to use what? Law of cosines instead. Okay, so let's try to use the law of cosines first. All right, so firstly, cosine alpha is what? Let's do this. By law of cosines, the law of cosines, we have cosine alpha equals, what is cosine alpha?
B squared plus C squared minus A squared over 2BC.
2BC, yes. The sum of the squares of the two adjacent sides, right? So that's going to be B squared plus C squared. B is 6.0128 square plus c squared 12 square minus a squared 10 square over 2 times 6.0128 times 12. That is going to be cosine alpha, right? So what is that? Equals what? Remember to use parentheses, all right? Parentheses on the top, parentheses on the bottom. Anybody got it?
Is it 0.5554?
Yes. You got this? Okay. Should be got this 0.5554. Should be this one. Okay. That's the value of cosine alpha. Anybody got this one, or anybody got a different answer? Okay, so remember to use the parentheses, all right? Parentheses on top and parentheses on the bottom. Okay, so you should have got this value. Now, if cosine alpha equals this one, what is alpha? Cosine inverse, right? Inverse cosine. Equals what?
90.9820.
9820. Very good. And if you change this one to rate, to this is in radian, right? Change to degrees. You can divide that by pi times 180, right? Anybody got it?
It is 56.3 degrees.
Yeah, 56.3 degrees. Okay, that's our alpha. And similarly, can we find the what, gamma? You can do that as well, right? So cosine gamma equals this will be a squared plus b squared, right? This one equals, okay. Anybody got this? Okay. Anybody got this one?
Got 28.86.
No, that's not right. So you need to firstly find the top, right? In the parentheses, and divide it in parentheses of the product. So what is on the top, right? And then divide the top by the bottom in the parentheses. Okay. So firstly, in the parentheses, 10 squared plus 6.0128 squared minus 1 to 12 squared, right? In the parentheses. Okay. Over the parentheses, 2 times 10 times that. So Mustafa, what did you get?
I'm pretty sure I'm wrong. It's 28.8.
No, that's not right.
Yeah, I don't know. I don't know what I did wrong.
Did you use the parentheses, please?
Yeah, I do the alpha y equals, and I click n1 and over d on the calculator to get a fraction.
No, that's not right. That's not 28. It's not going to be. Natalie, what did you get?
I got negative 0.0652.
That sounds right. That's what I get. Okay, so it should be negative 0.0652. Okay. For those who didn't get this one right, okay. So what do you do in the calculator? All right, parentheses. All right, input parentheses. Okay, 10 squared plus 6.10128 squared minus 12 squared. Close the parentheses. That's parentheses on the top. You got this? All right, after you do this, division divided by another parentheses. Another parentheses. Inside the parentheses is 2 times 10 times 6.0128. Then close the parentheses. Anybody got this?
Mhm.
So be careful, right? So, Mustafa, did you get this one? Good?
Yeah.
Okay, good. Just be careful when we are doing the ratios using the calculators, right? This is a completed fraction. Now you want to use the parentheses for the top and parentheses for the bottom. And then do the division, right? Otherwise, it will come with errors. Okay, so just be careful on that. Cosine gamma equals this one. Then what is gamma?
Inverse cosine.
Inverse cosine of negative 0.0652. This one equals
1.6360.
very good. 1.6360, and then this change it to degrees. That's what? Times divided by pi times 180. What did you get?
93.7.
93.7 degrees. Okay, so we got what? Missing the unknown side, b. All right, is found is to be what? 6.0128. Alpha is 56.3, and gamma is 93.7. Right, so everything is known now. Good. Yes. Okay, this is how we can do using the law of cosines to solve a triangle, right? So especially when what? One triangle is given and the two adjacent side is known, right? The two adjacent side is known. Then we can directly find the other side. After we find the other side, all the sides are known, then we can find the cosine value of any angle we have, right? Of any angle. Now consider another one. 中序
Find the angle alpha for the given triangle if side A equals 20, side B equals 25, and side C equals 18.
Okay, very good. All right, so very good. So how can we do this? Now, of course, we are using the alpha is the opposite side of A. All right, so the this. All right, this is alpha C This is gamma. This is alpha. This is beta. All right, so we are using this. Okay, so this is going to be A, this is going to be B, this is going to be C, right? So now, like this one, right? Now, how to find alpha? We can use what? All the sides are given, so we can use the law of cosine, right? To find the cosine alpha and then solve for alpha. Yes? So what do we have?
Cosine alpha equals b squared plus c squared minus a squared over 2bc.
Very good. Right, cosine alpha. All right, solution. By the law of cosines. All right, cosine alpha equals b squared, 25 squared, plus c squared, 18 squared, minus a squared, 20 squared, over 2 times 25 times 18, which equals, all right, now do that again, right? So see if you can get this one right. In the parentheses, all right, be careful. Let me know what you get.
0.61.
0.61. Yes? Okay. So that's exactly, all right, 0.61. That's what I get. Okay, so this is 0.61. Okay, I found cosine alpha is 0.61, then alpha equals what? Inverse cosine, right? What did you get?
0.9147.
147. Well, this is in radian, but converted to degrees.
52.4105.
Okay, we can just round to 1 decimal place for degrees, right? So that's going to be
52.4.
52.4 degrees. Very good. Yes. Did you see how we do this? Good. Okay, very cool, right? Okay. Wow. Let's consider this one. Arinda, can you read for us, please?
Yeah, on many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway running east to west, and the cell phone is north of the highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway.
Okay, very good. Okay, very good. All right, so now this is a very interesting application, right? So how the GPS can locate the cell phone, right? So how can you use these towers to locate a cell phone? Okay, usually the person carries a cell phone, right? So you can locate location of a person or a vehicle, right? Or a vehicle. Okay, so now, okay, all right. So let's say that this is A, this is B, now here is C. Yes, A, B, and C. Okay, so let's see what we know, right? We know that the lengths AB are given, lengths AC are given, the side BC are also given. So the three sides are given, right? The 3 sides are given. So what do we want to find? Determine the position of the cell phone north and east of the first tower. North and east, right? So that's going to be the coordinate. If A is the what? Origin, right? If A is the origin, then what is the location of C, right? So we want to find the value for C. So basically we would need, okay.
You just use the height as from the
This
sun.
one, yeah, and also this side, and this one, right? Correct? We need these two distance. Say this is X, and this may be the Y, right? For this point, correct? So the north is Y, north, right? So this feet north, right? And this feet to the east, correct? Of the first tower, right? So you need to find X and Y. And then what? Determine how far it is from the highway. I believe the highway is highway is what? I believe it's 2 towers or
I think it's a cell
along a
phone.
street
Is it a
highway.
cell phone?
No, I believe the 2 towers. This side AB is the highway, right? This side AB is the highway, correct? Because the 2 towers are located this part along a straight highway, right? AB is the highway, right? So now we want to find how far it is from the highway. So this C is the point. Highway is the side AB. So basically that's Y. Yes. The distance from a point to a line, that is what? Take the straight angle, right? Take a right angle, and then you can find this is going to be Y is going to be the distance, right? Y is going to be the distance from the highway. Yes. So basically, it's just to find the X and Y. If X and Y are found, then Y is the distance from the highway. Yes. Okay. All right. Now, how can we do that? How can we do that? Well. Yes, that's right. Okay.
I'd find an angle first.
Yeah. You got to find the theta, right? If you can find the theta, then I believe X is simply what? 5,050 theta times cosine theta, right? And Y is going to be just 5,050 theta times sine theta, right? So then that everything's good. But can we find the theta, cosine theta? Well, we need cosine theta and sine theta, right? Okay, given all these 3 sides, can we find cosine theta? Very simple, right? So by the law of cosines, the cosine theta can be easily found. Yes? Okay. Solution. Okay. Cosine by the law of cosines. We have cosine theta equals what? The square of the 2 adjacent sides, that's what? Plus 6,000 square minus. Yes? That's on the top over 2 times 50/50 and times 60,000. And what did you get? Anybody got this?
I got 0.9183.
Very good. That's exactly what we get. 9183. Right, cosine theta equals this one. For this one, we don't have to find about angle theta, right? You don't have to because we just need a cosine theta, right? So then what is going to be x? Fifty times cosine of theta, right? Equals 50 times 0.9183.
I have a question.
Yeah, go ahead.
Why didn't we use inverse?
Now for this one, because it depends on what is our purpose, right? What is our purpose? Now for this one, we only need the value of x and the value for y, right?
Yeah.
So now x equals what? Simply is a 50 times cosine of theta, right?
Yeah.
So we do not need the value of theta because cosine theta is already known, just plug in, right? So we already can easily find the x. That's already, our purpose is already we already got that, right? So we don't have to find a value for theta and then do cosine and sine, right? So you don't have to do that. Does that make sense?
Okay.
Yeah,
Yeah,
because yes, x is already known or can be found directly, right?
Yeah.
Okay. So what did you get?
4,637.175.
175. Very good. All right. So this is my x values, right? Then can you find the y value? Now, y value can be found in multiple ways, right?
Mhm.
Now, firstly, using Pythagorean identity, you can easily find the y, right? 50 is the hypotenuse, right? This x value is already found, this one. So y equals what? Square root of 50 square minus 4637.175 square. Yes, this can be easily found, right? Using Pythagorean identity. Square root 50 square minus 4637.175 square. What do you get?
1,999.7770.
Yes. Right? So that's going to be our y value. Now, can you locate this one? So we can say that what? Hans, the cell phone is what? Y is 1999.7770 feet, right? To the north of the first tower. And what? 4637.175 feet to the east of the first tower. Good. Basically, that's what we mean, right? So that's what we want to find. And how far is this one from the highway? Easy, right? So that's going to be y. Okay, it is 1999.7770 feet from the highway. Easy? Yeah, this example is a real life problem. We just need what? To interpret this problem and translate into a trig problem, right? A trig problem. Using the law of cosines, we can find the cosine of theta, and everything else can be found easily. Okay. All right, so consider another one here. All right, so let's say Joshua, can you read first, please?
Suppose a boat leaves port and travels 10 miles, turns 20 degrees, and then travels another 8 miles. How far from the port is the boat?
Very good. All right. So it didn't say in what direction, right? It didn't say anything about this direction. So let's just say this, right? So we have a port. Say this A. All right, so this A. It travels 10 miles. Okay. Anywhere, right? Let's just draw a. Okay, this is 10 miles. I got B, point B. Okay, and turns 20 degrees. 20 degrees means what? Clockwise, right? Counterclockwise is a positive degree, right? Counterclockwise. So it is something like this. And then travels, this is 20, this 8 degrees, 8 miles. So it's something like 20 degrees is smaller, right? Something like this. Let's say this. Then it got to point C. How about this? Yes?
It says from A to B travels 10 miles, it wrote 20.
Oh, 10 miles. Yes, this is 10 miles. Okay.
So 10 and A almost be the same length.
Yeah. That's right. Let's say here, right? So here. Okay. Let's say somewhere here. How about that? Let's see, right? So this point is 20 degrees. Okay. So, and then we want to find what? The distance.
See.
AC, right? So that's basically what we want to find. Can we find, so we know what? We know the side AB, we know side BC, that's 8. And do we know the angle included by these two sides? What is
It's
that?
120 minus 180 minus 20, it's 160.
160, right? So very good. All right. So the angle CBA equals 180 minus 20 degrees, 160 degrees, right? So hence we have AC squared, right? So AC squared, let's say this is B, right? So this is B, okay? So B squared equals what? Using, we have by the law of cosines, B squared equals 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of what? 160 degree, right? So what is this? Anybody got this?
For the cosine 160, do we have to put the degrees sign for it?
This one is a degrees, right? In degrees.
So we have to put degrees. second angle.
Second angle, what do you mean?
Like with the degree sign on top of it, second degrees angle on 3 degrees.
Oh, yeah. Second angle, yeah, degree, yes. Using a calculator, right? So that's right. So because this 160 is in degrees, right? So you got to do that. So what do you get?
314.3508.
3508. Very good. That's b squared. So this implies b equals square root of this, right?
17.7
17.7 what?
299.
299, right? Okay, so that's good. That's gonna be the distance from the part to the boat, right? So it is what? 17.7299 miles from the part to the boat. Make sense? Okay. Yes? Okay, all right. So now here is the so-called Heron's formula. Okay, Heron's formula. This Heron's formula is just use the size of a triangle to find the area of the triangle. Okay, so the oblique triangle. So Heron formula finds the area of the oblique triangles in which the sides A, B, C are known. Okay, so this is the formula. The area equals square root S times S minus A, S minus B, and S minus C. So where S equals A plus B plus C over 2 is 1/2 of the perimeter of the triangle, or you can call it called a semi-perimeter. Semi-perimeter, that is S, or S equals semi-perimeter. Good. All right, so we have S equals the semi-perimeter, and you can just, after A, B, and C are found, we can find the semi-perimeter, and then the area, you can just plug in the formula. Everything will be good. Okay. All right, let's consider example here. Okay, let's consider example using the Heron's formula. Okay, so consider this example. 钟旭
Use Heron's formula to find the area of the triangle with sides of length A equals 29.7 feet, B equals 42.3 feet, and C equals 38.4 feet.
Okay, very good. All right, so very good. Now, could you please go ahead and use this formula to find the area? So you firstly need to find the semi-perimeter. What is S, right? No. Anybody got this?
Yeah, 552.3180 cubic feet.
80. I got a different value. 50. Rounding.
79.
Yeah, 3179. Yeah.
Okay, I'm sorry. Yes.
Yeah, you don't have to clap, right? So that's the area, right? You see, the Heron's formula is pretty handy, right? So just given these three sides, you can easily find the semi-parameter, and using the formula you can find this one. You don't have to find the the sine of theta or cosine of theta, or using the 1/2 AB cosine theta, cosine gamma, right? So we do have that one as well, but for that one you need to firstly find the sine, the sine, right? The sine of theta, then using 1/2 times that, right? But this one is given the three sides. You can just use the three sides to find the area, which is in many cases, in some cases, it's very handy. Okay,
I have a question.
go ahead.
In the exam, we can use anything we like. We can combine laws of sines and cosines. That's fine.
You can do that, right? But if I say that, okay, use Heron's formula to find this, then you have to do that. Have to,
Okay.
like this example, right? We are told to use Heron's formula, right? So then you got to do that, correct?
Okay.
Okay. And if without this use Heron's formula, then you can use whatever you want, right? So I believe this is the same one, right? This is the same one.
Yeah.
All right. Okay. All right. So we are done with section 4.2. Okay. Now, the test will be just here. All right. The law of cosines. Okay. So I won't cover anything after this section 4.2. All right. But we still have 10 minutes. All right. So we are going to make full use of these 10 minutes for our lectures. Okay. So let's move on to section 4.3. About the polar coordinates. All right. So about polar coordinates. Now, polar coordinates, we want to introduce the polar coordinates, which are points labeled as R and theta. Okay, R and theta plotted in a polar grade. Polar grade. What do we mean by a polar grade? Now, the polar grade is scaled as the unit circle, as we can see from the graph here, right? So you can have the unit circles, right? Circles, different circles. They have the co-centered circles, right? With positive x-axis, all right? And you can see 1, 2, 3, 4, and negative, or you have everything like this, all right? So -1, -2 as well there. With the positive now viewed as the polar axis, and the origin as the pole. All right, this x-axis as the polar axis, origin as the pole. It is something like if you have a signal tower, right? If you have a signal tower, the tower is in a pole area, and then it will give signal to the nearby area, right? To the area nearby, right? So how depending on the distance, all right, to the tower, and you have these different circles and so on, right? So the x-axis now viewed as a polar axis, origin as a pole. And then you also have an angle for any point in this coordinates. Okay, so for instance, I have this 2 as the polar axis is 2, so it is in the same same circle, right, as this 2. So the distance from this point to the origin, which is a pool, is 2, correct? It's 2. And the angle is, well, measured in radian, indicates the direction of the R. All right, this angle, as you can see, it can be what, pi over 4, right? It can be pi over 4 indicated here. So 2 pi over 4. That is the, you know the distance from the pole, and also you know the direction, right? Also you know the direction, so it will fix that point. We move counterclockwise from the polar axis by an angle theta and measure directed line segments. The length of R in the direction of theta, then we will have this one, like this one, right? So if we move counterclockwise by angle of theta for this one, it is angle of pi over 4, right? Pi over 4. And then this distance, this of length is 2, so it is 2 pi over 4. Okay, so that's what we get for this one, polar grade. Make sense? Okay. Now, the first coordinate R is the radius or the length of the directed, okay, of the directed line segments from the pole. Okay, so if R is negative, since it's directed, the length of the directed line segments, okay, it can be negative. All right. So if R is negative, then the point P is absolute of R units from the origin along the ray in the opposite direction of the terminal side of theta. So in other words, for instance, we say negative 2 pi over 4. Okay, negative 2 pi over 4. So we are going to have what? So this is 2, right? So you're going to turn what? This angle is pi over 4. So you got to this angle here. This is the direction, right? The angle is pi over 4. Okay, it's counterclockwise pi over 4. However, this point P is at what? Since R is negative 2, right? It's negative 2. So you're going to take the absolute value of negative 2. That's 2 units from the origin along the ray in the opposite direction of the terminal side of theta. So that's going to be what? The opposite direction. That is a P, which is what? Negative 2 pi over 4. Does that make sense? Now, of course, this one is the same thing as what? 2 and what? 5 pi over 4, right? It's the same thing, right? So the direction you go 5 pi over 4, and then the distance you can go what? Positive 2, right? So that's going to give you the same point, P, right? The same point. Make sense? Okay. As long as you got a radius and also a direction, then you can determine that position. Yes, you got the position. Consider Mustafa. Can you read for us, please?
Plot the points 3 pi over 2, negative 2 pi over 3, and 2, negative pi over 6 on the polar grid.
Very good. All right, let's do that. Okay, so let's consider, just draw a polar grid here. Okay, so we have 1, 2, 3. Okay, so we would need a circle of 2, a circle of 3. So this is 1, 2, 3. This negative 1, negative 2, negative 3. Okay, so now let's consider the 3 pi over 2. So what is 3 pi? Where is 3 pi over 2? Now, firstly, it's a pi over 2, right? So pi over 2 is what? Right angle, right?
Yep.
So that's going to be the y-axis here, right? So it's going to be this one, this direction. So it is 3. The radius is 3 is positive, right? It goes along the ray. So that is at this point. That's going to be 3 pi over 2. Correct? Okay. Now what about negative 2 pi over 3? We got to do what? You go counterclockwise by pi over 3. So it might be somewhere here. But the radius is negative 2. So we go what? By the opposite direction, right? Go the opposite direction. The distance what? What is the line segments? The length is what?
2.
2. So it is here, right? So it is this point. That is negative 2 pi over 3. Okay? So now let's consider the final one. 2 negative pi over 6. So what is the direction? This negative pi over 6, you do what? Clockwise, right? You do clockwise. So it is the direction is somewhere like this. This is the direction, right? This is the direction. But how long do we go from the origin? What is the distance?
2.
2. So 1, 2. It is this point. Yes? 2 negative pi over 6. It's here. So these are 3 points in the polar grid, right? So we got all of them. Yes? So you can see that given the radius and also the angle, where it determines the location of the point, right? Determines the location of the point. Very good. Now, here let's consider the conversion from polar coordinate to rectangular coordinates. To convert polar coordinates to a rectangular coordinates x, y, let what? Okay, cosine theta is x over r. And so we got x equals r cosine theta. Okay, sine theta equals y over r. So y equals r cosine theta. Oh, sorry, it's r sine theta. Or sine theta. All right, basically, it's just what? X is r cosine theta. Y equals r sine theta. Very simple. Very simple. Now let's consider this example, right? Nick, can you read first, please?
Yes. Write the polar coordinates 3 pi over 2, negative 2, 0, and 2 negative pi over 6 on a rectangular coordinates.
So let's consider the first. All right, 1. Okay, so it's 3 pi over 2. So r equal to 3, theta equals pi over 2. So what is that? X equals what? R cosine theta equals 3 times cosine theta, cosine pi over 2. What is cosine pi over 2? What is cosine pi over 2?
0. Or, yeah, 0.
0. Okay, so this one is 0. Y equals what? R sine of theta equals 3 times sine pi over 2 equals sine pi over 2 equals what?
1.
It's 3, right? So the xy coordinate is simply 0 and 3. Yes. Now this one makes sense, right? So as you can see from this one, this point 3 pi over 2 is what? Is 0, 3, right? At the y-axis here. Correct? Okay. So I think that's already time. We're going to stop here. All right. So in the next class, today there's no quiz. Yes, no quiz, but exercise problems from section 4.2. Yes, so work on that, and tomorrow we're going to firstly start with reviewing those problems, and then any other questions you may have about the test. If you do not have, if we still have time, we'll continue our lectures. Okay? So, okay, all right, that's all for today then. Thank you.
Tomorrow.
See you tomorrow. Bye-bye.